Today we're going to be looking at calculations on isotopes. So here's the first question on it. Chlorine has two isotopes, chlorine 35 and chlorine 37, with relative abundance or percentage abundance of 75% for chlorine 35 and 25% for chlorine 37 respectively. Calculate the average relative atomic mass of chlorine. Now don't forget, in our previous lesson we were made to understand that when we talk about relative abundance, we're talking about the rate or the proportion of the existence of a given atom of a given element in nature. So for the fact that we have two atoms of this element, we're talking about the same element, chlorine. But for chlorine 35, we have more chlorine 35 in nature. We have 75% of chlorine 35, a lot of chlorine 35 in nature, compared to chlorine 37, which is just 25%. That's what we call relative abundance. Relative abundance is simply how much of a given atom of an element we have in nature. Now, how do we get the relative atomic mass unit for this very given element chlorine using the relative abundance? Don't forget, a formula was given in our previous lesson, and that's why you have to go to that previous lesson. So for us to get the relative, most times we'll call it average relative. For us to get the relative atomic mass for a given element, so what we have to do is simply this. It's very, very simple. We just have to get the summation, which is sigma, we call it sigma, summation of the partial atomic mass unit, or the partial relative atomic mass unit of isotopes, of each of the isotopes given to us. Now we can see we are given two different isotopes, chlorine 35 and chlorine 37, and we are given their percentage of existence in nature. So for us to get the relative atomic mass of chlorine, what we just have to do is to get the partial atomic mass of each of those isotopes. Now, how do we get the partial atomic mass of each of those isotopes? Don't forget, by the time we get the partial atomic mass, then we add them up. So how do we get that? This is how we get the partial atomic mass. That's going to be the summation. Let's see how we get the partial atomic mass. So that's going to be isotope abundance. Isotope abundance, that's what it is, over 100 times the relative atomic mass of each isotopes given to us, over 1. This is how we do it. This is how we solve for the partial atomic mass of isotopes. This is how we really solve for it. So by the time we get the isotope abundance is just like 75. Look at this. Chlorine 35 is 75% in nature. So isotope abundance over 100 times the relative atomic mass of that very given isotope. So by the time we get